Hey guys, so let's discuss new round from Microsoft interview loop, which is the round 8 code production incident. Okay, so the scenario is given to you is CPU usage suddenly reaches 100%, then what you will do. Okay, so before jumping on to the answers, let's see about the question, right? So this one is the highest frequency Microsoft production engineering round. Okay, and you will get this kind of round. Unlike a normal troubleshooting interview, Microsoft want to evaluate whether you can handle incident calmly, troubleshoot using data, and then prioritize customer impact, work systematically, lead production incident, and prevent future occurrences. Okay, so means a common mistake people do generally by saying restarting the pod or increase the CPU. Okay, so Microsoft expects in an incident response methodology, not random debugging. Okay, like a step by step what you will do. So again, expectation differ by level. So we will be seeing here answer from three roles, which is software engineer, senior software engineer, and architect. So what software engineer will say, 2 to 5 years of experience, that he will diagnose the issue methodically using logs and metrics. Okay, then senior software engineer, 6 to 12 years of experience, he will say that coordinate mitigation. Okay, mitigation means reducing the impact or risk of a problem, identify the root cause and minimize customer impact. Okay, now principal engineer will say, he will be architect. Okay, 12 years of experience, let's say, lead the incident, coordinate multiple teams, make architectural decision, and derive long-term reliability improvements. Okay, so now let's see what software engineer will say. So the expected answer from him would be, the first priority is to understand customer impact before making changes. Okay, I would verify whether the CPU spike is isolated or affecting the entire service. So first you will check that what is the customer impact, okay, or whether it is an isolated service or it is impacting complete system. And then check application health, gather metrics before attempting any mitigation. Okay, mitigation means reducing the effect, like you will roll back the deployment, let's say, so something like that. So immediate investigation flow would be something like this. You will get the CPU alert, let's say. Okay, so he will verify the customer impact, how many customers are impacted. Okay, or then he will check the dashboard, he will inspect the log after that, and then he will identify the root cause, and then he will go with the mitigation plan. Then he will monitor the recovery. Okay, let's say he did a rollback, and then he will check after rollback everything is working fine or not, like earlier. Now senior software engineer, who will have a 6 to 12 years of experience, he would be saying that the expected answer from him would be, I would follow a structured incident response process. Okay, first establish the service to reduce customer impact. So he is also concentrating of reducing the customer impact first, and then the mitigation plan. Then investigate using metrics, log traces, and JVM diagnostics. Only after identifying sufficient evidence would I decide whether rollback, scaling, or restarting the is appropriate. Okay, sometimes it is not always required that you need to roll back it. You can auto scale. Okay, you can increase the number of pods, or you can restart the system also. Then he will check according to the metrics he will get. Okay, so the incident response flow will be something like this. Alert will happen. Okay, then he will declare that this is the incident. He will declare incident. Okay, then he will check the customer impact, and then on the basis of metrics, logs, and tracing, okay, he will check whether mitigation is required or not, and then what mitigation is required, and then he will root cause the analysis. Okay, RCA he will find. Now the goal is here, restore service quickly. Okay, so that customer impact would be minimum. Then protect users, preserve evidence, minimize downtime, and avoid unnecessary restarts. Principal engineer or architect will say, for this is, during a major production incident, my first responsibility is to service restoration while coordinating engineering, operations, and different stakeholders. Okay, so first he will again he will concentrate on reducing the impact, okay, customer impact, and then he will coordinate with different teams, like the infrastructure team, the DevOps team, okay, engineers, operations, stakeholders. I would assign parallel investigation stream, communicate status regularly, and ensure we collect enough evidence for a meaningful postmortem. Postmortem means you need to check why this issue happens before you will not blame anybody. Okay, but you will postmortem the incident. Now postmortem the issue. Okay, now enterprise incident architecture will be something like this, like that. So alert happen, okay, alert raise. Incident commander, he will assign one incident commander who will coordinate with the infrastructure team, application team, database team, and networking team. Okay, after that they will find the mitigation way. Then they will recover it, they will find the RCA, and then reliability improvement, so that in future this issue not occur again. So now guiding principle would be here: customer first, evidence-based decision, parallel investigation, clear communication, and blameless postmortem. This is the important one. Okay. Now let's talk about few follow-up questions here. We will be talking about 15 to 16 follow-up questions here. Okay. The first question is first 5 minutes what you will do. So software engineer will say that I would verify whether customer are affected. Okay. Check if all pods are only subset of high CPU. Okay, means all pods are affected or subset of the pods have the high CPU. Okay, or review recent deployments and then check dashboard and avoid restarting services immediately. First he will find the RCA, and then whatever is required on basis of that he will take the action. Now senior software engineer will say that his priority would be first the customer impact he will check, then he will check the recent deployment, then he will check metrics logs, and then he will go with mitigation. Now principal architect will say that within the first 5 minutes, okay, declare the incident if needed. After that, assign owner for infrastructure, application, database investigations. Okay, commander he will assign. Then freeze non-essential deployment, begin stakeholder communication, focus on restoring services before deep debugging. Okay, he has to initiate the stakeholder communication also. Let's say he has to talk to the leadership team or the management team. Okay, what is happening about he will give the live status also. Now follow-up question 2 is which dashboard you will be checking. So different role will check different dashboards. So for example, software engineer will check CPU, memory, pod health, request rate, and error rate. Okay, and then senior software engineer will also monitor percentile 95, percentile 99 latency, then garbage collection activity, queue depth, thread count, and database latency. Okay, then principal architect will review dashboard at multiple levels. Now what will be his levels? The first one is infrastructure, then Kubernetes, then application, and then business. Okay, so what he will check in infrastructure? He will check the node CPU, node memory, and network throughput. Okay, and then in Kubernetes he will check pod restart, and then HPA, horizontal pod auto scaling, and then node pressure. Now in application he will be checking the latency, error rate, and request throughput. Okay, so here he will check the network throughput in infrastructure, and here in application he will check request throughput. Now business, he will check the active user, transaction, and failed request. Okay, to check the impact, business impact. Okay, follow-up question 3 is related to logs. Okay, so software engineer will search for exception, logs, timeout, means these things he will search in a log: exception, timeout, and repeated errors. Now senior software engineer will correlate logs using request ID and trace ID. Okay, so we know that trace ID, span ID we use for the in microservice. Okay, to track the request and to track where the error is coming, in which service. So now principal architect will use structured centralized logging. Okay, filter log by deployment version, region, services, and correlation ID to reduce investigation time. Again he will check the same thing, but he will check the centralized logging, the dashboard where he will get the all the data. Okay, like Splunk or something. Now follow-up question 4 is related to heap dump. Okay, so in heap dump software engineer will say that he will capture a heap dump if memory usage keeps increasing. Okay, if the error is related to memory, then you go with the heap dump. Now senior software engineer will say that he will analyze for large object retention, okay, memory leak, and excessive cache. Excessive cache also make the trouble, right? Excessive cache means, let's say you have used cache on for the browser, for CDN level, application level, Redis level, database level, CPU level. So all these things will make the system very slow. So excessive cache is also will create a trouble for you. Now principal architect will say that he will capture heap dump before restarting pods whenever possible, so evidence is preserved for root cause analysis. Okay, next one is thread dump. So thread dump, software engineer will say that he will collect a thread dump to identify blocked or busy threads. If you need to identify issue on thread level, then thread dump will useful for you. Now senior software engineer will say that he will look for deadlock, infinite loop, and long running request. Okay. Principal architect will say that he will capture multiple thread dumps a few seconds apart to distinguish transient spikes from persistent issues. What is transient spike and what is persistent issue here? So it means that whether it is a temporary or ongoing issue. Okay. Now follow-up question 6 is related to database issues. Okay, so database issues means software engineer will say he will check the slow queries, connection pool usage, and database CPU. Okay, and then senior software engineer will investigate lock contention. What is lock contention? So it means that multiple threads are competing for the same lock, causing some threads to wait until the lock is released. So you have one lock and you have multiple threads, and they are competing to get that lock. So if you have to wait, right? So that is the lock contention. Then missing indexes and query plans. Now principal architect will say that he will determine whether high application CPU is caused by excessive retries. Okay, means let's say you have a high CPUs. This is the problem, right? It's high CPU you got. So he will check that how he is getting it, why he is getting it, whether it is caused by the excessive retries or connection pool. Okay, connection pool exhaustion or insufficient queries. Scale or optimize only after identifying the bottleneck. So first he will identify the bottleneck and then he will scale it or optimize it. Okay, follow-up question 7 is related to network issue. So software engineer will check the packet loss, latency, and connection failures. Okay, related to network. Software engineer will review load balancer health, DNS, and cross-service communication. Okay, after that, principal architect will use distributed tracing to identify whether CPU spikes are consequences of a retry storm caused by network degradation. Okay, follow-up question 8 is related to memory leak. So software engineer will check the symptoms of a memory leak. Okay, what all symptoms are there? Let's say memory continuously increasing, or frequent garbage collection is happening, or eventually out of memory error he will be getting. Senior software engineer will use the heap analysis tool to identify retained object and investigate cache growth or unclosed resources. Okay, so let's say few objects are retained. Okay, they're not getting freed. So he will check the heap analysis tool, and he will find this kind of objects, and then he will check why cache is growing. Okay, why time to leave is not working, or eviction policies are not working, and then if there is any unclosed resources. Okay, so they are also causing the memory. Principal architect will implement memory usage dashboard and automate alerts to detect leaks before they impact production. Okay, so he will modify the dashboard according to the requirement what he needed. So now follow-up question 9 is related to JVM tuning. Okay, so software engineer will review heap size, garbage collection logs, and JVM options. Okay, for the JVM tuning. Senior software engineer will tune G1 GC or ZGC. Okay, these are the garbage collection algorithms. Optimize the garbage collector setting to reduce pause times and improve performance. Okay, because of garbage collections also system this one takes the more CPU. And then heap sizing, so allocate a right amount of JVM memory to avoid frequent garbage collections or out of memory errors, right? And then thread pools, so configure the optimal number of worker thread or to efficiently handle concurrent tasks. Now what principal or architect will say about it? So benchmark tuning changes under production like load before rollout. Okay, so just do the let's say just give it a production kind of load. Okay, before deploying it, so just test it, like kind of a kiosk testing. But in kiosk testing actually you try to break the system. Here you are just increasing the load. Okay, so now avoid changing JVM parameters during an active incident unless there is clear evidence they are causing. Okay, so JVM don't change the JVM parameters until you don't have a proof or the evidence. Now follow-up question 10 is related to rollback. So software engineer will say that rollback if the issue started immediately after the deployment. Okay, that is the one thing we do. And senior software engineer will say that confirm the deployment timeline before the rolling back. Okay, first check the at least the deployment timeline, and then principal architect will say that rollback should be fast. Okay, automated and low risk. So it's not that manually you're rolling back the changes. It should be automated. Okay, you just click a button and then it will again roll back to the previous version. Low risk, always compare recovery time against the time required to diagnose and fix the current release. Principal architect will say that Now follow-up question 11 is related to scale horizontally. Okay, so software engineer will say that increase the number of application ports if the CPU saturation is caused by increased traffic. Now a senior software engineer will say that on the scale after confirming the workload is stateless and bottleneck is compute related. Now principal architect will say that scaling is mitigation, not a root cause fix. Okay, you're just a you're reducing the impact, okay, by scaling, but you're not fixing the root cause, right? If the issue is deadlock, memory leak, or runway query, additional replicas may simply amplify the problem, correct? So now follow-up question 12 is related to restart pod. So directly don't jump to restart the pod, restart the system. First discuss these things in a step-by-step manner, and then come to here and then say about the restart pod that software engineer will say that he will restart only if the service becomes unhealthy or unresponsive. Senior software engineer will say that capture log, heap dump, thread dump first whenever possible. Okay, so whenever you're restarting the pod, just collect all the metrics. Okay, principal architect will say that use rolling restart instead of restarting every port simultaneously to avoid complete service disruption. Okay, so it should be automated. Follow-up question 13 is related to postmortem. Okay, so software engineer will document the timeline, root cause, resolution, and lesson learned. Now, senior software engineer will include customer impact detection gap, corrective actions, owners, and target completion dates. Okay, and principal architect will conduct a blameless postmortem focused on improving systems and processes rather than assigning faults. Follow-up question 14 is related to prevent recurrence. Okay, so that the this issue should not occur in future. So software engineer, what he will do, he will add alerts, improve testing, and fix the root causes. Okay, now senior software engineer will implement better monitoring, load testing, capacity planning, and automated rollback, which is very important. Automated rollback. Now principal architect will strengthen reliability through chaos engineering. Okay, you are intentionally adding the failure into the system to check whether it is getting failed or not, and how you will handle it then auto remediation, and then progressive deployment, capacity forecasting, and reliability reviews. Follow 15 is related to monitoring improvement, how you will improve your monitoring observability. So software engineer will monitor CPU, memory, and error rate. Okay, senior software engineer will also monitor, apart from those three things, he will monitor thread count, garbage collection cost, queue depth, database latency, and cache hit ratio. And what principal architect will monitor here, create dashboard covering infrastructure, Kubernetes, JVM, and application. Okay, and then business. So in infrastructure, he will capture CPU, memory, and network related things. And then Kubernetes, he will add pod health, HPA events, okay, hibernate, pod auto scaling event, and then node utilization. JVM, so he will check the heap usage, GC pauses, and thread count. Okay, then in application level, he will check the throughput, latency, and error rate. And in business level, he will check order processed, active user, and revenue impacts. Now follow-up question 16 is related to SLA, SLO, and error budget. Okay, now what is SLA, SLO? So, and what is error budget? Error budget means these many errors you can have. Okay, so okay, software engineer will say about SLA is that this is service level agreement. Okay, a contractual commitment to customers, like example 99.9% monthly uptime. We are guaranteeing, we are giving you guarantee for this, and if it is not meeting, then you can charge us. Now SLO is a service level objective, so an internal reliability target, for example 99.95% availability, and percentile 95 latency should be less than 200 millisecond. Okay, so this one service level objective. So these are the objectives we are setting now inside that agreement. Now what is in error budget? So in error budget, the amount of acceptable unreliability allowed before showing feature releases. Okay, so for example SLO is 99.9%, let's say you have committed, so allowed downtime is 43 minutes per month. Okay, you can have 43 minutes downtime per month. Okay, and then if the error budget is exhausted, focus shift to from new feature to improving reliability. So don't concentrate on the new feature, first you improve the reliability of a system. Okay, and then proceed further. So now senior software engineer will say that use SLO to guide engineering priorities, monitor error budget consumption continuously, and if it's being depleted too quickly, pause risky deployments and prioritize stabilization first, work first. A principal architect will say that he will use the reliability framework. Now, what is in reliability framework? The business promises reliability through an SLA. Okay, you do service level agreement, right? Then engineering aim to meet it using SLOs and SLIs. Okay, SLIs indicators. So, and the remaining error budget determines if the team should continue releasing feature or first improve the system stability. Right, this is what we have seen. So now here SLA is promise made to customer, and SLO is reliability target for engineers. SLI is the metrics like availability, latency, error rate used to measure the performance, let's say. And error budget is allowed downtime or error before releasing. Before releases should slow down, and reliability work takes priority. So now error budget help balance innovation with reliability. Teams can release rapidly while staying within acceptable reliability limit, but once the limit is budget is exhausted, engineering effort should shift towards improving stability rather than shipping new features. So that's it. Thank you.